Hi, and welcome everyone for today's webinar on increasing your data productivity using Amazon EMR Notebooks. My name is Vignesh Rajamani, and I'm a Senior Product Manager with the Amazon EMR team. In this session, I'll be introducing you to EMR Notebooks. This is a new feature that we introduced last year in November prior to reInvent. I'll be walking through the personas that can benefit from this product and why you should use it. I'm going to show you a quick demo of how it works and how you can access it. And then finally, we'll open it up for Q&A. So let's get started. So what are EMR Notebooks? EMR Notebooks is a managed notebook environment provided by Amazon EMR that is based on Jupyter Notebook, that's a popular open source Jupyter Notebook, and it allows data scientists and developers to build applications with Apache Spark, perform interactive analysis using EMR clusters, prepare and visualize the results of your computation within the notebook, and then collaborate with your peers. So it's a managed offering that is based on the popular open source Jupyter Notebook. This slide shows you a quick schema of the architecture of EMR Notebook. Users can log into our AWS management. This is how you access it. Users can log into the AWS management console for EMR, navigate to the EMR page, and then spin up multiple notebooks serverlessly from the console. These notebooks would be hosted inside our EMR VPC without any access to the internet. And then from here, it connects remotely to the computer, to your cluster running inside your VPC. It connects to the master node instance of your cluster through security groups, and it submits Spark jobs remotely on your cluster through the Livy that is installed on the master node of your cluster. The notebook also gets auto-saved to your S3 bucket. So you don't, if your cluster terminates or if your cluster shuts down, you don't have to fear losing your work as it's automatically saved at frequent intervals to your S3 bucket. So this is the architecture of the EMR notebooks in a nutshell. What are the personas that can benefit from it and why should you use it? If you are a data scientist or a developer, you can use EMR notebooks to build Spark applications. Jupyter Notebooks, EMR Notebooks that is based on Jupyter, supports Spark Magic kernels, and it allows you to remotely submit Spark queries running on your cluster through SpiceSpark, Spark SQL, Spark R, and Scala. So you can use any of these programming languages to build your applications. As I mentioned before, you can create multiple notebooks instantly from the console. A single user can create many notebooks and attach to them to a single cluster, and this cluster can be as small as a one-node cluster and immediately start experimenting with Spark. Multiple users can log into the console and create multiple notebooks. Each user will get their own notebook, and so there is no fear of collision between your work, and they can all attach to their cluster, or they can all attach to a shared multi-tenant cluster that you have access to. EMR Notebooks also is integrated with Spark Monitor, so this allows you to monitor the progress of your job right next to the code where you're writing your code. And I'll show this in the demo as well. EMR Notebooks is also packaged with open source libraries from Anaconda. And this helps you to visualize the results of your computation using the many rich graphical libraries that are available in the open source Anaconda repository. Another great benefit of using EMR notebooks is that your EMR notebook is not tied to a single cluster. You can easily detach a cluster from the notebook, attach it to a different cluster suitable for your workload. Again, I'll show this through the demo. Finally, as I mentioned, your work is automatically and durably saved to S3 bucket that you have access to. And you can easily retrieve your previously saved work from going to the console. So in case the cluster shuts down or Spark crashes, you don't have to worry about losing your work as it's durably persisted to S3. So that is for the data scientist and developer. If you're an IT administrator, why should you allow your end users to use this? EMR Notebooks provides you with an easy way to set up a multi-tenant cluster. As I mentioned, multiple users can log into the console, create their own notebooks serverlessly, and they can all attach it to a single shared cluster that you have provisioned for them, thereby making most use of your EMR cluster. Since EMR Notebooks is a managed offering, there is no need to deploy, maintain, or upgrade the software or the notebook instances. All this is done for you by the EMR service team. The EMR Notebooks are hosted inside a private VPC without any internet access, so it provides a very secure way of accessing your cluster and running queries remotely on your cluster inside your VPC. You can also safely terminate your cluster for maintenance without fear of losing notebooks, as they are all durably persisted to S3 at frequent intervals. Since the notebooks are hosted in the console by us, it is tied. You can set up fine-grained access control to these notebooks through the IAM policies. You can also enable user impersonation when you create a cluster, and what EMR Notebooks will enforce this user impersonation, thereby allowing you to track and audit your notebook users and see who did what when. What programming languages and libraries can I use? As I mentioned before, EMR Notebooks support Spark Magic kernels. Spark Magic kernel is a set of kernels like PySpark, SparkR, Spark SQL, and Spark Scala kernels that allows you to remotely query Spark running on your cluster. We also support standalone Python kernel for small local jobs that you want to execute within the notebook. We also prepackaged EMR notebooks with a lot of open source Anaconda Python libraries. So you can import and use these libraries and visualize and display the results of your computations in rich HTML graphical plots. You can also install your own libraries on the EMR cluster if you have a need for running some specific Spark packages. These can be installed on your cluster either through a bootstrap action or by building your own custom army. One requirement for using EMR notebooks is that you should have a running EMR cluster. And this EMR cluster should be running EMR release 5180 or later, and it should have Spark and Libby installed. I will demonstrate this through the demo as well. Now to the most exciting part. What is the cost of using EMR notebooks? There is no additional charge to using EMR notebooks. You can create multiple notebooks instances and attach them to your cluster, and you only pay for the use of the cluster as usual. There is no charge incurred for the notebook itself. The number of notebooks that you can provision and attach to a cluster is dependent on the size of the master node, and this we have documented in our release notes for your reference. So if you have a large cluster, if your master node instances of type, say, large, then you might provision 4 notebooks. If you have an X large master node instance type, you could get 8 notebooks and so forth. And again, this is documented in the EMR release notes. There is no charge for the EMR notebooks, but you will be charged as usual for the attached cluster. And you can find the rates for these. You can find by visiting this Amazon EMR pricing page. We also have an offering from SageMaker notebooks that you might be aware of. And there might be a confusion when you want to use EMR notebooks and when you want to use SageMaker notebooks. So this slide attempts to answer that question. If you are building machine learning models, SageMaker is your choice. It should be your choice. SageMaker is built for machine learning and for general purpose ML loads that runs outside of EMR. But if you're a data engineer or a data scientist that want to experiment with Spark or run big data applications and develop big data applications on EMR, then EMR notebooks, you'll find EMR notebooks and easy to access and build those applications. So if you're primarily concerned with Spark applications, use EMR notebooks. If you're using it for machine learning or other ML models, then SageMaker is the way to go. Now let me show the demo. And it's go navigate to the Amazon EMR section, and on the left navigation panel, you'll see a link for notebooks. Click on this notebooks, and you'll be presented with a notebook creation page. Click on the blue button where it says Create Notebook and provide some inputs that are required to complete the creation. First would be the notebook name. So let's provide with a name that is suitable. Let's say Spark NB1, NB2. Provide a description of the notebook, Spark doc jobs. Once you are done with the notebook name and description, here is where you choose your cluster. One point to note about this is the cluster that you're attaching it to should be available for the duration of the notebook session. So the notebook should always be attached to a cluster. If the cluster terminates for some reason, or then your notebook will be shut down after a short period of time. But don't worry, it will still be saved to the S3 location that I talked to you about, so you won't lose your work. Now, in this cluster page, there are two ways of attaching to a cluster. You can choose an existing cluster. This is a cluster that you have already access to. Maybe your IT administrator have already provisioned for you, or you have provisioned it previously. So you can click choose, and this will show you the list of clusters that you have access to. You will see only clusters that are running inside a VPC that is running at least EMR release 518 or later, and has Spark, Hadoop, and Libby installed. These are the requirements for the cluster to be compatible with the notebook. If they are, you will see a list of clusters that are compatible. Just choose a cluster that is suitable for your workload. Let's choose this EMR Spark Hive cluster. Once this cluster happens to be in a waiting ready state, so let's just choose this. And this is what it will be attached to. As I mentioned, there's another way you can attach to a cluster. That is, if you don't have an access to an existing cluster, you can quickly create a cluster from this notebook page, workflow page itself. And that is the create a cluster option. Click this and you will see the cluster populated with all the defaults. The cluster name would be notebook cluster. It will have the latest EMR release, which happens to be EMR 520 now. It will have all these applications that are required to be installed for it to be compatible. And it will choose, it will provide, you can choose the instance type. It will have a default populated, but you can choose an instance type that is suitable for a workload. And this instance type, again, can be as small as a one node cluster. Let it be one. I can choose maybe the M4X large, and it will create a one node M4X large cluster here. And these are the roles that are required for this cluster to talk to other AWS services on your behalf. If you're familiar with EMR, you should be familiar with the roles. If not, you can navigate to this tooltip, or you can navigate over release notes and read more about roles. If you need to customize these roles, or if you need, then we suggest that you go back to the cluster creation page and provide those options, because this here is really intended to be a quick way to create clusters, so it will be populated only with defaults. Let's go back to choose an existing cluster, and let's choose the cluster that we already have up and running. After you made a selection on your cluster, then you have to provide security groups. As I mentioned before, notebooks connect to the master node instance of your cluster to submit queries. And it connects to the master node through instance to security groups. There are two security groups that are required. One provides the inbound access to your notebooks for your notebook to the master node instance for you to submit your query on the master node instance, and a outbound access from the master node instance back to your notebook so that you can visualize the results of your computation back into your notebook. So you need to provide two security groups. You can either let us create the security groups. If you have permissions, EMR will automatically create these security groups for you. And these permissions should be provided in the service role that I'll talk about. Or you can provide your own security groups that allows access to the ports, that allows inbound access to the master node instance port and allows an outbound access from the master node back to the notebook. If you're unfamiliar with the concept of security groups, I suggest you hover over on this tooltip and navigate to the release notes where you can learn more about security groups. Then you need to provide a service role. This is very similar to the EMR service role that you need to provide when you're creating a cluster. But Notebook requires its own role, and we have a managed policy that is available. So you can create a role, say a Notebook role, attach the managed policy that is already available to that role, and you should get started, and you can get immediately started. If you want to customize your own role, you can also do that, and we have documentation of what permissions are required, minimum permissions are required for this role. So you just navigate to this Learn More page. Here you will see all the permissions that are required by this notebook to attach to the cluster and talk to other AWS services on your behalf. You can create a policy that is very similar to this, or a much scoped down policy than this, and attach to your service role and get started. After you have provided your notebook's AWS service role, you need to provide a location for your notebook. This is an S3 location, and this should be it should be in the same region as where you provisioned your cluster. My cluster happens to be in the North Virginia, US East 1 region, so I should create a bucket. I should have a bucket that is residing there. There are two ways of providing this bucket, again, similar to the cluster. One is you can let AWS as EMR service create this bucket for you with the standardized prefix. That's what this does. So if you don't pick your own bucket, we will create a notebook with this prefix inside in this North Virginia region and store your notebooks inside it. Or you can pick your own bucket by clicking this folder picker here. After we have provided a location for S3, then there is another concept that I want to familiarize you with. That's the concept of tags. Before I go to tags, I want to tell you that EMR notebooks are shared resource, just like an EMR cluster. And what I mean by that is anybody who has access to your account can see the notebooks that you have created, open them, modify them, and even delete them without your knowledge. So if you are the owner of the notebook and you're the author of the notebook, and if you want complete control over your notebook, you can create what is called tag-based policies, resource policies. And this tags, we have created a tag for you that is unique to you that will help you write such policies. So this is a creator. So if you're the creator of the notebook and if you logged into the IAM, this ID here that you're highlighting is very unique to you, and you can write policies that restricts anybody without this ID from accessing or opening or deleting your notebook. So only author and creator of the notebook will have access to open them and edit them. You can easily this is just for help you to get started to write this. You can write your own tags, or you can delete this tag and create your own tags and write policies based on that. Once you have provided all the required inputs that is required, just click on Create Notebook. And this will take you to the notebooks, what is called the notebooks details page. And this notebook details page, and right at the top, you will see the status of your request. You will see go through three states. One is starting that you just saw, and immediately transitions to pending. In this stage, the notebook is getting attached to the cluster that you chose, and once it gets attached, it should shift to a ready stage. That means the attachment to your cluster is complete, and you're ready to run your queries on that cluster. Just click on the refresh button, and there it is. In a matter of seconds, it's go to the ready stage. Now, how fast it goes to the ready stage from the starting stage depends on how you are provisioning your cluster, how you chose your cluster. If you already had a cluster that was in the waiting stage and you chose that as an existing cluster, it will go from starting to ready stage in a matter of seconds. If you're provisioning a cluster from the notebook page that I showed you about, that's with all the defaults, then it will take some time for you to see this ready state. That is because the cluster needs to come to the waiting stage for the notebook to attach it to the cluster. So that takes some time. It won't be long. It should be in minutes, but you have to wait a little bit longer if you choose that option. So once it's ready, you can click on the open notebook, and you should be able to see your Jupyter UI. I'll show you that shortly, but before that, let me expand on other details that you're seeing in this page. This is the notebook ID. In case there are any issues with your notebook, this ID will be really handy if you when you file a support request, so that we can debug what's happening with the notebook. This is the description that you gave when you provision the notebook. This is the last modified, and then this is the last modified by option. This last modified will have the on of the user who last modified the notebook. In case you have not implemented tag-based policies, this would be a quick way you check who last modified your notebook. If somebody else, if John or Robert modified the notebook, it will have their on ID shown here, so you can see who last opened or modified your notebook. I am the user, I'm the creator of this notebook, so it has mine on here. And this is the service role that I chose to use. Again, I chose to use the default role that was there. You can create your own role and attach to the policies by navigating to the roles and policies page that I showed you. This is the tags that the notebooks have been created with. You can delete this and create your own tags, create multiple tags, and write policies based on those tags, restricting users to only access to those tags. Again, you can navigate our release notes and learn more about how to write tag-based policies. This is the location of the notebook where your notebooks are saved. In case you want to download your notebook, you can go to this S3 location. All the notebooks all will be saved as IPYNB files. You can download this and maybe share it with your colleagues or open in a local copy of Jupyter Notebook if you want. And then there is the cluster section. This shows you the cluster that you have attached it to, what is the status of the cluster. If it's a waiting cluster, it's ready to open. If the cluster was just booting, it will have a different stage, and then you need to wait for the cluster to come to waiting stage before you'll go to the ready stage and you're ready to open the notebook. But our cluster is already in the waiting stage, so let's go ahead and open this notebook. Once you click on open, you should see the familiar Jupyter Notebook UI, and there you go. You can start typing your code and all execution will happen on the cluster that you attached it to. Let me open a notebook that I have already created. I'm going to open this EMR notebook. This is currently in the stopped stage. Let me start it again. So this notebook has been stopped because it has been left lying idle after a while, or you stopped it. So I want to resume. This is where you go and resume a notebook that you have previously saved and begin your work. So currently it's a start date. Let us start it again. When you're starting the notebook, make sure it is attached to a cluster that is in the waiting stage. If the cluster is no longer, it's been terminated, or it's no longer available to you, then you will not be able to open your notebook. Let's wait for it to. Go to the open stage. There you go. It's in the open stage now. So let me open this notebook. I'm opening this notebook because I have some code already written and I want to show you the Spark monitor that I talked about in my opening of my presentation. It's a small piece of code that just to show you the capabilities. So I have a small text file and I'm just running a word count job from this notebook on a text file that is residing in the S3 location, in an S3 location that my cluster has access to. So let me run this code. So this is the first time when you're running the application, there'll be slight delay before you see the results of your computation. That is because the notebook needs to start the Spark application for the first time. Subsequent cells will execute much faster than this. So it is currently starting the Spark application on your cluster. This is the yarn ID. This is the kernel. I'm running PySpark kernel. While it's going, I want to show you the different kernels that we have application, or actually it executed. So this is a small job that got executed. And here is while it was executing, this is a small task, so you didn't see it. But if it had been a longer running job, you will see the Spark progress. And if you click on the Spark job progress, you will see the different stages of this job and what the status of each stage. If some stage, if some task had failed due to some errors, you will see a link here of for the S3, and that link will take you through the logs that are in your S3 so that you can see what went wrong with your job. So as I mentioned before, I'm running a PySpark kernel. I have access to, you can change your kernel depending on the on your code to Python, Spark, Spark-R, different options that we are providing. That is with the notebook itself. Now let's say I found that this cluster that I have currently attached it to is not suitable for my workload. I want to change it to a different cluster. What do I do? So I first stop my notebook. You can close the browser or stop it, it doesn't matter, but let's stop the notebook. It goes into the stopping status now. After a while, it will go to the stopped stage, and once it goes to the stop stage, you will see a change cluster option enabled here. So let's go back to a notebook that is already stopped so that I can quickly show you how to change your cluster. So this is a notebook that I had created previously that's currently has been stopped. So, and it is attached to a cluster, and that cluster actually got, I terminated that cluster. So this shows you the cluster status. So if I start it, it won't start because it is currently attached to a cluster that has been terminated. So I need to change my cluster. So I come here, I click on change cluster. You can also change your cluster because you found that your current cluster is not suitable, that is already running is not suitable for your workload. Whatever reason, you can change your cluster. So choose an existing cluster. Okay, again, you can create a new cluster, but let's choose an existing cluster so that it's faster. I choose the Spark demo cluster, and then I can change and start notebook. Again, it will go to the starting stage, it will go to pending, and then finally it will go to ready if there is no problems with this. Now it's in the pending stage where it's trying to attach to this cluster that I just chose. And it's there. Matter of seconds, it goes to the open ready state, and then you can open your notebook, and that's how you change your cluster. You can also delete this notebook if you want, and what it does is it deletes it from the console view only. It will still reside in your S3 bucket that you chose when you created this notebook, so you can always download it from that location if you accidentally delete it. But if you want to delete it from the S3 itself, then you need to go to your S3 location and manually delete it yourself. Delete option here just deletes it from the console view. And these are all the list of notebooks that I have previously worked on. I can quickly resume any notebook from the same workflow that I just shared with you. And that's it for our demo. So to quickly reiterate, what you need to do to open EMR Access and use this feature is you should have EMR console access. Once you have this access, you navigate to the AWS Management Console for EMR and choose Notebooks from the left navigation panel that I showed you. You should click Create Notebooks, enter your notebook name and some brief description. Then you should provide a cluster. You can either choose a cluster that you have already provisioned to the EMR cluster page, or you can instantly create a new cluster from the notebook page that I showed you. You should provide a service role. This is very similar to the EMR service role, but not quite the same. And there is I showed you the link to documentation where the required permissions have been documented. There is also a managed policy available, a default policy that are available that you can attach, create a role and attach the managed policy to, and to get you immediately started. And finally, you should provide an S3 bucket. And this S3 bucket should be in the same location as your cluster. You can either provide your own S3 bucket or quickly have EMR service create a bucket for you as default with a standardized prefix. Once all these required inputs have been given, you just click create notebook once again, and you resume you'll be provided with this familiar Jupyter UI. So that's it. And now we are ready for Q&A.